In this problem from section 1.3, number 35, we were asked to find the value of the six trig functions using the point xy on the terminal side of the angle, theta, that's in standard position. So our point is x is negative 3.75 and y is negative 2.5. So again, this isn't necessary to solve the problem, but just to get a visual and understanding of what's going on here, I want to draw a picture. So I have negative 3.75, negative 2.5, so maybe about like here. And we're using this little triangle to solve for this angle. But those numbers are kind of ugly. So if I try to stick those into r to solve for r, remember that r is equal to the square root. Remember, r is this little length here, while this is y and this is x. So for r, it's y squared plus square root of y squared plus x squared. And if I try to square those ugly decimals and take the square root, that's going to be kind of challenging to do without a calculator. So to do this without a calculator, my little calculator here, no calculator, my method is to use similar triangles. So if this is a triangle, if this is our angle, if I keep going all the way out here, this is still the same angle. It's the same rotation of that terminal side. It's exactly the same angle. But I can use a similar triangle with some bigger length. So the question is, what point, this new point, I'll call P, I don't know, P prime, will make it an easier problem to solve. And let's see at the answer. So I want these decimals to go away. Both those decimals are a part of like a fourth. So 7.75 is 3/4, 0.5 is 2/4. So if I multiply both of these by 4, then I'll get a similar triangle, but that's further out with whole numbers. So I'm going to use this alternate x1 and y1, where I take the original smaller triangle and multiply by 4. So 3.75 times 4, I'm gonna, so you can do that, you can convert it to a fraction or do two-column multiplication, whichever you prefer. I'm gonna do the multiplication, so that's 20, 28, 29, 30, 12, 13, 14, 15, and my decimal is 2 places, so my new x is 15. So this length of the similar triangle, I have a 15 for x. And y, do the 2.5, it's a negative 15. 2.5 times 4, that's one's a little easier, that one's just 10. So that's a negative 10. So this is a negative 10 right here. And to find that r, I'm going to plug in the larger triangle's coordinates. So let's see, that would be the square root of, r is always positive, so don't worry about the negative square root, but it's a positive 15 squared, yeah, a second, plus negative 10 squared, which gives me 15 squared is 225, 10 squared is 100, which gives me square root of 325, and that I can break down. So let's see here. Let's see, what are the root tree of 325? So that's the 325 breaks into 5 and let's see, 65, another 5 and 3, 13's prime, but I do have 2 5s I can take out. So that gives me 5 squared times 13, which is 5 times the square root of 13. So there's my new r. And now I can use that r along with this x and y to find those 6 trig functions. So let's see. We have sine of theta equal to the y over r. And we're going to use the bigger triangle for y over r. So that is negative 10 over 5 radical 13, which equals negative 2 times radical 13 over 13. Let me double check that's right. Wait. Yeah, that's right. And then the cosecant of theta is the reciprocal of that, so that's, I'm going to take the reciprocal of the other one, so that's going to be negative radical 13 over 2. Yep. And then let's see, cosine of theta is x over r, which is negative 15 over 5 times the square root of 13. I'm going to leave that unrationalized for right now. Negative 3 over radical 13, because I'm kind of running out of space, so I'll just leave that unrationalized, especially since that way I can flip it over easily to get secant, which is going to be negative radical 13 over 3. And then tangent of theta is y over x, which is negative 10 over negative 15, which is positive 2/3. So cotan is the inverse of that, or the reciprocal of that, which is 3/2. So it's kind of squished down there, but the tricky part of this problem is finding that similar triangle x, y, and r.